Hi guys, welcome to another fun day of Algebra Online. Today we are going to look at inputs and outputs. So if we plug something in, what does the output look like? And a little bit different than what we've been doing so far. So let's take a look. I want you to pause this video and write down this table. It's really important to also give yourself a nice good title too. So this is lesson 123, 1.2.3, which is the same in your textbook or your online textbook. So if you go to your book and you find chapter 1, section the 1, 2, 3, this is what it is about. And so it's good to kind of have the notes with the title that is the same as your textbook so you know where to go in the textbook. It's also really helpful. Okay, so the question is, what is the relationship? What is happening here in this table? And I just want you to try to see if there is any patterns. And just taking a look at it, if I look across with the x's, the only pattern that I see is that it looks like it's going, it's bigger each time, like adding one, adding one, adding one, adding one, adding one, adding one. That's good to know. Okay, so mental note, x's are increasing by 1 each time. And then I don't see a pattern here. So this is subtract 5, subtract 3, subtract 1, add 3, add 5. Oh, wait a minute. I see there's a pattern here. I see 0, 3, 8. I see a 0, 3, 8. And then I have this one that's in the middle. Ooh. So when that happens, I want your brain to think quadratics. And we were doing this when we were graphing the quadratics, is we had seen where there was like that pattern for the y's, even though this table's like turned sideways instead of up and down. Okay, so that means that we're dealing with a quadratic. So I'm going to write that y equals x squared, because we did recognize that pattern. So when you see that pattern, write y equals x squared. So then we have to ask ourselves, if we take, let's say, because these are the x's, if I take a 3 and I plug it in for x, I get 3 squared. And 3 squared is 3 times 3. Now 3 times 3 is 9, but I didn't get 9. I got 8. So that means when I plug in 3, I need to get to 8. So couldn't we just say it's subtracting by 1 then? And if that works, make sure that it works for every single one. So let's try, let's try the 2. Okay, so if I take 2 and I plug it in for x and I say 2 squared, 2 squared is 4, minus 1, I get 3. Hey, it looking like it's checking out. Okay, so if I plug in the 1 squared is 1, minus 1 is 0. Awesome. Even if I plug in like 0, right? 0 squared is 0, minus 1 is negative 1. So that is the rule, right? That is the equation that goes with that table. So instead of giving you this and you have to finding these, we kind of went backwards. I gave you the table and then you found the equation. Okay, cool. Let's take a look at a second example, except this table has missing parts. So let's try to piece together and find the relationship, find a pattern, and see if we can write the rule. Okay, so my brain goes to the ones that are already finished. So I ask myself, how do I get from 49 to 7? How do I get from 25 to 5? Well, if I take the square root of 49 is 7, and the square root of 25 is 5. Let's see if I use that same strategy for every single one, right? Because I can also take the square root of 1 and it becomes 1. So that's what I'm claiming the strategy is. So let's write that out. So in order to get y, I am taking the square root of whatever is in the x. See that? Whatever is in the x, if I plug it in, it's going to give me y. So if I take 49 and take the square root of 49, it gives me 7. So let's take the square root of all of the x's and then write them down below. Okay, so the square root of 9 is 3. The square root of 100 is 10. The square root of 4 is 2. Something, when I take the square root of it, it gives me 4. Well, that is 16. The square root of 16 is 4. The square root of 0 is just 0. The square root of 25 is 5. The square root of 20 is not perfect. Not perfect. And in fact, you can type it on your calculator. So let's do that, right? I'm going to type in the square root of 20, and I'm going to get a decimal. Decimal is 4.47, and that's okay. We're going to have to write that one in there. It's not perfect, but it's fine. So 4.47. So there is a different type that's written. Instead of the y, you see that it says f of x. And that's a fancy way to say y. So I can rewrite the y equals the square root of x to say f of x equals the square root of x. And now I know that it seems kind of weird, f of x, and that maybe you're like, can I just write y? Well, and why do we even do that? Well, that guarantees, when you see f of x, it guarantees that it's a good working machine. Think of like a pop machine where you press a button and you want Mountain Dew and you press the button and a Coke comes out and you're like, what the heck? But if you know it's working, it works every single time, then it's good to know, right? And so that's really what this f of x means. It means that it works, okay? Because sometimes things don't work. So, and we're going to explore more about f of x, which means that it's a function, means it's a good working machine. So now let's talk about those machines. So here is a function machine. And we've kind of been doing this already, guys, right? If you take 3 and you plug it in for x, 3 squared is 9 minus 1 is 8. But do you see how it's written differently now? Instead of y equals, we have f of x, and our answer says f of 3. That tells the reader that you plugged 3 in and you got 8. So now let's do that for 4. We're going to use the same machine, this function machine, because we know it works, and we're going to take 4 instead of 3. We're going to take 4 and plug it in. All right, so let's do that. So now we have the x squared, but now it's not x anymore. Now it's 4 squared minus 1. Now 4 squared is 16, 4 times 4, minus 1 is 15. So we would write that f of 4 equals 15. That's what our answer looks like. Okay, let's do the next one. Let's try 10. So it's now going to become 10 squared minus 1. Now 10 squared is 10 times 10, which we know is 100, minus 1 is 99. So we're going to say f of 10 equals 99. Let's do it again for negative 1. So I am going to plug in negative 1 to my x squared minus 1 machine, and now it's going to be negative 1 squared minus 1. Now negative 1 squared is negative 1 times negative 1, which is a positive 1, and 1 minus 1 is 0. So we would say that f of negative 1 equals 0 as our final answer. So guys, we were just taking the 4, the 10, and the negative 1, plugging them in for this machine, and then performing this math to get our final answers. All right, now what if we had no idea what was going into our machine, but we knew what came out? Could we tell what we were putting into the machine? For sure we can. So what we would do is we would write down that with the f of x equals the x squared plus 2, we know what the f of x equals. the f of x equals 27. So I'm going to put 27 where I see f of x in the equation. So I'm going to write 27 equals, and it equals x squared plus 2. So now we're going to solve and get x squared all by itself. So that means we're going to subtract 2 to the other side. And we have 25 equals x squared. What that means is that there are two numbers, that there are the exact same number, right? X times x, because there are two of them. If I multiply them together, I will get 25. And that is 5, right? Because 5 times 5 gives us 25. So in this case, we found that x is 5. Because when we take 5 and plug it in, 5 squared is 25 plus 2 gives us the 27. Cool. All right. So the last example, I know might be really hard for you to copy down in your notes. And so maybe just watching this a couple of different times would be a good idea. Let's take a look at the graph and let's see what's happening in this graph. So in this graph right here, I have a parabola, which is an x squared, which is what we've been learning about. And it's telling me that when I plug in a 1 into the graph, weird, right? That I get a -1 as the output. So my input is 1 into a graph. I'll show you what that means. And then my output was -1. Okay, so that is telling me if I go to the x-axis, right? The x-axis. And I find a +1 on the graph. So here is +1. Where is my graph at? It's at -1 on the y. So our input is the x, okay? And that's important, so let's write that down. The input is the x, and then the output is the y. So output is the y. And in this case, they like to write it fancy, like g of 1. But we know that that means y. It could be f of x, it could be g of x. It just changes because it's math, which is super cool. But we just know it's y. All right, so now that we are a little bit comfortable with reading this graph, let's look at it again since it's our last problem. We got time. Okay, so if x, my input is 1, I'm going to go to the x and I'm going to find 1. And then my graph is right here. When it's at 1 for x, for the y, it's at -1 because here's 0, 0, here's -1. So that's how to read it. Okay, so here's the question. What is the output? What's our y? When the input is +2. So I'm going to go to the x and I'm going to find +2. So here's 1, 2. And where is the output? Where is my graph? It's right on it. But for the y, it's 0. Because here's 0, here's 1, here's 2. It's 0 when it's 2. So there we go, 0. All right, let's look at what happens when it's -1. So let's plug in g of -1. Let's look at -1 on the x. -1 is here. Where is our graph? It's up here at a +3. So we would say that the g of -1 equals 3. All right, let's take a look what happens when it's 0. So 0 is right here for x. Where is it for the y? Oh, it's also at 0. So g of 0 is 0. All right, and the last example, what is the input? Okay, so we're going backwards now. I want to know what is the input? What is the x when the output, when the y, and let's do that. Let's write that down. What is the input? What is the x when the y is -1? All right, so if the y, +1. If the y is a +1, which it's right here, that's where 0, 0, that's +1, what is the x is going to be? Well, looks like our graph at the y is 1, and I'm going to draw a line for that one. This is where the y is 1. So if you notice, our graph hits it twice, right? The graph is here and here. So when our y is 1, our x's, we have two different answers, and that's totally okay. It looks like this one is in between the 0 and the -1. So let's just, for right now, let's say it's halfway in between, and let's say that that is about -0.5. And let me show you that. So like it's right here, it's in between 0 and -1. And the other one is 1, 2, it's in between 2 and 3, so let's call it a positive 2.5. Now, I know this is the very first time that you are ever seeing this, so it might be confusing. You might have to watch this video over again. We're going to do this for several days. We're going to do some more tomorrow. We're going to do some more the next day. And I mean, I don't expect you to get this right on the very first time, and I don't expect it not to be confusing. It's going to be confusing because you're learning it for the first time and you're learning it from a video from home, and I know that's got to be pretty difficult, but I want you to hang in there. I want you to rewatch the video over again if you're stuck. I don't want you to stress out. I just want you to know that I want you to try every day and then zoom in with any questions and keep working hard. Okay guys, I hope you have a great day. Bye.